Let's get started. Hello and welcome to another Solana tutorial. Today we're gonna talk about transaction bundles by Jito, which is a really interesting topic. We have mentioned Jito before, and today we're gonna have a closer look into what they actually do and what their products can be used for, specifically bundles. So this video I'll focus on Jito Bundles. Now, full disclosure, Jito does support me financially to make this video, but I keep full creative control. They do not censor me and they do not tell me what to say. I'm completely free to make this video because I want to make this video. I reached out to them for a cooperation and they agreed. So this is what we're doing. So let's get started and talk about Jito Bundles. Now, before we actually talk about what they are, maybe let's start with a motivation. Why would you care? Remember how on Solana a transaction is atomic? And that means that either all of the instructions go through or the transaction fails. So as soon as one instruction fails, the entire transaction fails. Now, this is a great property that we might want to have for some use cases. But this property cannot be used on a transaction level. Every transaction stands by itself. So every transaction is its own thing that can either fail or not. But I can't do something like, only if this transaction succeeds do I want the other transaction to be executed. Because transactions are independent. And if I send two transactions to a validator, the validator might include one and ignore the other one, or succeed both, or one might fail and the other one succeeds. So we don't have any control over that. Unless we put the transactions in a bundle, which would make it atomic. And then I have the property on the transaction level that either all transactions succeed or none of them are even included. Now, this can of course only be done on the validator side, because the standard Solana, like the way Solana works with just forwarding transactions, you do not have any control over that. Only the validators have control over that. They could look at their transactions and be like, okay, I'm gonna group those transactions and I'll either include them or not, because the validator has control over which transactions it wants to include into the block. The validator can choose to censor something, throw out transactions, or order them in a way that the validator sees fit. The validator can also choose to not produce a block, right? That's up to the validator. But then it's up to us as a community if the validator does stupid things and, for instance, censors a protocol or whatever, that we don't stake with that validator such that it doesn't get to produce a lot of blocks. Social consensus. But we're getting a bit ahead of ourselves. The point is the validator has the control over which transactions to include into a block and in which order. So if you were to run your own validator, you could add some code which allows you to add your transactions exactly in the way that you want and only includes them if they all succeed and whatever other properties you might want to have. That works, but obviously you would only get to do those things in the slot where your validator is producing a block. If it's even producing a block at all. You need enough stake for that to happen. So running your own validator just to get to do those things, maybe not ideal. However, there's Jito. Jito does run validators. No. Jito provides the software for validators that can do things like working with bundles. A Jito validator is basically the normal Solana Labs validator client with some additional code that allows for transaction bundles and some other stuff. So you can now take your transactions, make a bundle, and send it to a Jito validator. At the moment, about a third of all stake weight is at Jito validators, so about every third block is produced by a Jito validator. So you can't do it in every block, but you still get enough opportunity. Yeah, so basically, you send your bundle to a Jito validator who will then treat it as a bundle and only execute if all the transactions go through. Otherwise, it won't even include those transactions in the block, because why waste block space if they fail anyway? So, but now the question is, why would a Jito validator do that? What's in it for them? Because, I mean, he could just treat the transactions normally, right? Why would I do that? Like, why would I run a different client? Well, tips. If you want the validator to actually include your bundle, you better tip that validator because it provides a service to you. It adds additional functionality. So you want to add a tip in your bundle that then goes to the validator. In reality, it goes to all the validators that run Jito because it's not just one and it should be fairly split. But yeah, the basic idea is that you need to add an extra tip to your transaction such that the validator actually accepts it. Now, not only can you bundle your own transactions, you can also bundle your transaction with another transaction from someone else. And then we get to MEV, maximum extracted value, where you can do things like arbitrage, liquidations, and fun stuff like that. But today we just want to have a look at bundles. How can we group our transactions together such that they're atomic? And then in the next video, we might look at searchers and doing arbitrage and this kind of stuff. Or maybe we even do it in this video. If I'm quick and if it's easy, maybe we do it here. We'll see how quick we are and we'll see how good the documentation is and how difficult all of that is. I have actually not tried this at all. I just have an idea of how it works. I haven't actually tried it myself. So I've just heard about it, but never done anything with it. So today, we're gonna actually do something with Jito Bundles. Let's go. So, Jito, Solana MEV, maximum extractable value. So we have two groups of people who could be interested in this Jito stuff. The validators themselves. Why? Because they can make more money than running a normal validator and by getting the additional tips through Jito. And then searchers, those are the ones who actually do the MEV, like extract the value from the transactions, like with arbitrage or whatever, and tip the validators. So those are the two groups. Then there's a third group actually that I'm covering here, the stakers, because Jito also runs their own validators and has a liquid staking token called Jito Sol. So they also have a staking pool where they allocate 2 Jito validators. Not all of them, but some. And that's yet again a different thing that is not the topic of today's video, just so you've heard about it. So yeah, there are Jito validators, and on those validators, we can work with bundles to do MEV. I mean, you can also do MEV without validator support, just that if you have validator support, you can be more efficient. But let's talk about the basics. I want to have a nice graphic. Yeah, that explains the... Okay, so incoming transactions. At a normal validator, all incoming transactions would go directly to the validator and it would be able to produce the blocks and what. With Jito, we have another piece here, the relayer, which basically forwards all interesting non-vote transactions to a block engine. And this is the Jito thing that then creates those bundles. Because essentially there are so many Jito validators and a bunch of searchers, you somehow need to coordinate them, right? And this is done with this block engine where the searchers receive the transactions that would be going to the validator, and then they have some time to look at them and be like, oh yeah, I want to build a bundle with this transaction, and then submit that to the block engine, which then forwards it to the validator. All vote transactions, by the way, do go directly to the validator. The block engine is not interested in any votes. So this thing is not part of the validator, but it then forwards the bundles to the validator. And the Jito validator handles those bundles and actually builds the blocks. The block engine decides which bundles go to the validator, such that the validator doesn't have to do all that thinking, right? It doesn't have to check, oh, this bundle and this bundle was submitted. They use the same state, so I gotta go with the one that tips me more. All of that is done by the block engine, and the validator can then just build the block because it's got enough stuff to do. And I might add corrections here if I'm not fully telling the truth. This is just how I imagine how this works. The searchers can be run by anyone, right? I could run my searcher. Also, anybody can run a validator. But the point is, the searchers are the ones who try to do the MEV. And today we want to be a searcher, just that we're not gonna extract much value. We're just gonna submit a simple bundle. We basically just send our bundle to a block engine, and that then forwards it to the correct validator. So for us, that connection, we don't need to connect to the next leader, the next Jito leader. We can just connect to one of the block engines, and the block engine will figure the rest out. So that's the high level overview. Let's look at some docs. We have the Jito Bundles, we have the mempool, and the shred stream, which allows you to receive shreds directly from the validator so you get data more quickly. The mempool allows for some higher delivery guarantees because there is no mempool on Solana, by the way. On Bitcoin or Ethereum, we have this mempool for all the transactions that want to be included in the block. And then the validators or the miners include the highest paying ones, usually, into the blocks. On Solana, we don't have that because all of them get directly into the block anyway. But since Jito has access to so many validators, they can build their own mempool and with that give basically higher guarantees for transactions actually being submitted. And also that is not the topic of today's video, so I won't deep dive into that. We might come back to it. But today we want to talk about Jito Bundles. Unlock sequential execution of transactions by using Jito Bundles, supported by the Jito Solana client. Sequential execution of transactions. So we can say this transaction needs to go before this transaction, which is nothing we can do with regular Solana transactions. I mean, we can, but we need to await a confirmation of the previous transaction, for instance. Then we can guarantee that, yes. But especially if you want to go like really short behind each other or even in the same slot, then you can't guarantee that without the support of the validator. But a Jito bundle allows you to do that. Have two transactions in the same slot and guarantee that one comes before the other one. Right. So let's go to the docs. Who is this for? A searcher trying to make money on MEV. A DeFi operator who would like access to sequential transaction execution. I mean, does it need to be a DeFi operator? I guess anyone who would like access to sequential transaction execution. Also an NFT guy. Because one of the use cases could be burn 10 PNFTs to get one new PNFT. And simply by the amount of accounts for each PNFT and the compute it takes to work with those, you cannot do that in one transaction. Because the transaction size is limited, compute budget is limited, so you need several transactions to do this. And if you want that to be atomic, so either burn all and mint that one, and as soon as one burn fails, I don't want to mint that one, right? And the others should also not be burned. It should be all or nothing. And with bundles, we can achieve that. So yeah, it doesn't need to be DeFi, just anyone who wants sequential transaction execution. So let's get started. We need a local key pair. Jito Labs. Jill. So we have an address done. We need a block engine URL. A list of block engine URLs can be found here. So that was this thing, right? We want to connect to the block engine that is run by Jito. And Jito has several of that. One in Amsterdam, one in Frankfurt, one in New York, and one in Tokyo. So obviously we want the one that is closest to us, which for me is Frankfurt. So this is what we'll need. Then a block engine API key, because it's currently API gated, with messages signed by a local key pair. The local key pair shouldn't contain funds and doesn't need to be related to the key pair you sign transactions with. So another local key pair. To get access to the block engine, we have to fill out this form. And I already did that because they said it can take up to 48 hours. For me, it was like 3 hours or so until they gave me access. So yeah, it was rather quick. So I'm done with that. The next thing we need is the on-chain addresses for tips. Now, this stuff, there are like 8 tip addresses that are operated by a program, tip payment program. And those are the tip addresses. Why do we want to have several tip addresses, not just one? Well, as we learned in one of the previous videos, bottlenecks. If everybody uses the same tip address, then that can't be processed in parallel, because obviously the tip address needs to be writable. So there are several. Oh, by the way, Jito operates on mainnet and on testnet. We're gonna work on mainnet today because testing in production. That's how we like it. Right, so we pick one of them. Which one looks the nicest? This one kinda, but then we don't take that. This one also looks cool with a double T watt what mood also looks nice. So really we should take the one that looks the least nice, or really we should take a random one. So let's take this one. Okay, mouse said it's this one, so we take this one. That's totally random, right? So I have that address. Remember that for later. What else? That's it. We might want a custom RPC, especially if we do some MEV, then we need a good RPC, but we'll be fine with whatever we have, I guess. Okay, now that we have everything that we need, let's look at bundles. Bundles allow sequential and atomic transaction execution on Solana. Let's send our first bundle. A quick way to get started is with this searcher example. Set up the repo, run the searcher CLI example. Before we do that, let's go through that. What are bundles actually? I mean, I've mentioned it before, but let's go through the docs. So it's a list of transactions, several transactions that are executed sequentially and atomically. So it's an all or nothing. All or nothing. Sequentially means we provide that list and they're guaranteed to execute in that order. It's a list, has an order, it executes in that order. Atomically means that bundles execute atomically within the same slot, so we don't cross any slot boundaries, and if all of them execute successfully, then they will all be committed on chain. So it's an all or nothing. Bundles can only contain successful transactions. For now, they might change that. But for now, all of the transactions need to succeed for the bundle to be submitted. If any of the transaction fails, then none of the transactions will make it on chain. Not even in a failing state. So they won't even put it in at all. I mean, they might put in that transaction when it was not part of a bundle and just submit this transaction individually. If the block engine received it as a transaction, you make a bundle with that transaction and submit it, but your bundle fails, then the transaction might still get executed, but just by itself. A user can send a bundle that contains multiple transactions and guarantee that they are all executed sequentially. And that's what we want to do today. Cool. How do they work? The Jito validator client has a special bundle execution stage, which knows how to execute bundles. I don't want to go too deep into the technicalities of that. That's how it looks like at the normal validator. Fetch stage, then the SIG verify happens, so the signatures are verified, and then we come to the banking stage. And in the Jito client, part of this banking stage, they have a bundle stage. So anyway, we as the user can now submit bundles to the block engine, and it will take care of sending the bundles to the validators running Jito Solana. And then the validators in their bundling stage actually add those to the block. When can I use bundles? Bundles only work when Jito Solana leader is producing the blocks. Obviously, only on Jito clients can we do the Jito bundles. But since about a third of the stake is with Jito clients, about every third slot is produced by a Jito client. Therefore, we can do that in about every third slot. And then there are some examples what we could do with bundles. Arbitrage. So the user submits a transaction and directly afterwards we do our ARP. Or liquidations, the Oracle updates their data, and we know with that update there are some positions that we can liquidate, and then we add our liquidation transaction directly after the Oracle transaction to be the first one to do the liquidation, right? We don't want to wait for that to actually be on chain because then somebody else might already be faster. So we want to be directly afterwards, like the next in the next tick of the slot. And batching DeFi operations. If we can't do something in a single transaction due to transaction size limits or compute budget, we can send it as a Jito bundle to the block engine. Again, in my opinion, it's not just DeFi operations, it's any operations where you want several transactions to be executed atomically and sequentially. So, how do we actually send a bundle? Sending bundles is currently free, but API gated. Check out our send bundle command in the searcher CLI. Today we'll just have a look at this CLI and see if we can submit bundles. And of course, we need to tip. The current minimum tip is 1,000 lamperts. So that's a fifth of a transaction fee for the minimum tip. But even with the minimum tip, the validator should include it because we're not doing anything where somebody else out tips us and some tip is always still better than no tip at all. In order to tip validators, a user needs to submit a sol transfer to any of the tip addresses on chain. So we just need to do a transfer, and it says here the tip should be in the last transaction of the bundle, because if we include it somewhere else, it could get stolen by a malicious validator. Why? Well, because it has all the signed transactions. So, well, how would it actually do that? It would just submit that one where the tip occurs, but then not submit the entire bundle, for instance. But that it could also do with just the last one, no? Or another user on the network if it ends up on a fork. I'm not 100% sure how they would do it. If I think about it, I could probably figure it out. But anyway, we just, for now, remember that we want to have it in the last transaction in our bundle. Note that tips don't prioritize transactions. So this is different to the priority fees, right? Priority fees are something additional. And if we tip the Jito validators, we don't need to add priority fees, in my opinion, because Jito validators are already incentivized to include our transactions over other transactions, unless their priority fees are really, really high. How does the block engine determine which bundles are sent? Maybe also interesting. First, it does the basic sanity check. So, are these actually transactions? Are they signed properly? So, are the signatures valid? And is there less than or equal to 5 transactions in a bundle? So apparently the maximum is currently 5 transactions per bundle. Also good to know. Then if that's all true, we do the simulations for the transactions. So will all of the transactions in this bundle actually succeed? And how much is the bundle paying compared to other submitted bundles? So with the bundles, we're always, as with priority fees, we're in this market competing for the same state. If somebody else wants the same transaction in a bundle, then the one who tips more, that bundle will be executed. And then the auction, oh wait, that's done here for the auction check. Bundles are split into groups based on what state they read or write. And then bundles are simulated and ordering from highest to lowest payer. And then the top n highest paying bundles are selected. I guess let's just try this. I've been already talking for an hour. I want to get to the actual meat of this. I'm vegan, but still. Block engine. Oh, that's a nice graphic as well. Yeah, so we have those 8 tip accounts where we have to tip to, which is also part of the transactions that we submit in the bundle, that we submit to the block engine, and the block engine forwards it to the correct next Jito validator, who will then actually include our bundle, if all the checks went through, you know. Ingesting bundles and transactions from searches. So incoming transactions are relayed to the block engine, and the block engine also additionally receives bundles from users directly, like from a searcher, and then forwards them to the validators. Since the Jito pipeline is very latency sensitive, yes, obviously, because we have like 400 milliseconds to build a block, so if the transaction comes in, then we send it to the searcher, and then the searcher uses some time to send it back to us. And then we still need to have enough time to sort that by tip, do all the simulation, and then forward it to the validator to actually put it in the block. So like very latency sensitive. But for us, if we just submit our own transactions, we're not that time sensitive, because whether our bundle is executed with this validator or the next one, we don't really care. For our use case, if we don't use a transaction that is already being submitted, then we're not that critical latency. Right, so we wanted to check out this. Yes. So, searcher examples. 4 examples. One is a background, which is a searcher example, and the CLI, this is a Rust program. So with this, we can do sending test bundles. That's what we want to do today. Use at your own risk. So let's look at the CLI. Actually, let's clone this entire thing. It's just one Rust file. Mempool accounts, mempool program, next schedule leader, connected leaders, tip accounts, send bundle with an RPC, the payer, message, number of transaction, Lampert's tip account, and where are the actual transactions? Okay, so do we have, yes, we have docs, great. Oh wait, that's the background, hold on. Yeah, cool. So git submodule update init recursive. No idea what that does, but let's just run it. Build. Let's see if we can build it. But with my computer... Okay, whatever that did, not like I care. This is gonna be the interesting part. Pretty sick, bro. Nice. Alright, so this is building something. It's got a lot of dependencies though, and my computer is slow. So this is gonna take a while, which means I'm gonna take a break. And I'll see you later. Uh-oh, that does not look good. That does not look good at all. Could not find protoc. This build cannot proceed without this knowledge. I mean, it doesn't seem to be such a complicated thing. It just needs a package. I install a package. Done. In the meantime, we can already look at this. Find the code where it submits a bundle. Build and sign transactions. So, I think this is where we need to write our code. So apparently in each of the transactions we just tip, which is not how this is supposed to work. I mean, I would just tip in the last one. So here we basically just bundle some memos together. And then we send bundle with confirmation. Yeah, so essentially that's what we want to call in the searcher client. So that seems to be the SDK. Searcher client doesn't even have a README. Searcher client, an example on how to authenticate with a block engine as a searcher. Okay, and the CLI uses this searcher client. Okay. Okay. How are we doing with installing? Oh, failed again. This file contains proto3 optional fields, but experimental allow proto3 optional was not set. I hate it if stuff doesn't build out of the box. Make sure that protoc is larger than 3. Discord for finding things. Nice. Before compile, we add an argument. And try again. And wait again. That's usually what takes the most time. Building stuff. Getting stuff to compile. Oh, but this one seemed to compile. This was the issue earlier, right? Looking good. Well, ask me again in 25 packages. Now it's getting interesting again. Now we compile the Jito searcher client. Hey, we're done. How long do we wait for this now? Definitely more than 30 minutes. But hey, we have the finished build for the Jito searcher CLI, which means I should find that somewhere here in target release searcher CLI. Nice. So that means I should be able to execute target release Jito searcher CLI. Yes, look at that. I can start this. Nice. So searcher CLI, and then my commands are mempool accounts, mempool programs, next scheduled leaders, connected leader info, tip accounts, send bundle. So let's start with something simple. Getting the tip accounts, because we know what that should return. This list, sorry for the flash. Oh yeah, we always need the block engine URL and we always need the key pair path. Let's get this sorted. So we always need the block engine URL, which, careful, it's gonna get white. We said we're gonna use the one from Frankfurt. Then it always needs a key pair. And then the command is going to be tip accounts. Okay. Connects to searcher, permission denied. Supplied public key is not authorized to generate a token. Nice, because this was a key pair that I just created. Let's use a different key pair, the one that I actually signed up with. I have that here, G24, that's the one that I actually signed up with, and see if that's different. Yes! I mean, this is not very well formatted, but we do remember those addresses. Those are the tip addresses. Okay, cool. So we can connect to a block engine and we can do stuff. So what are we interested in? We could look at specific accounts whenever an account is mentioned or whenever a program is mentioned in transactions in the mempool. Because this mempool, that's where we can take the transactions from to build bundles with it. We can get info on the next scheduled leader. Maybe we just do that for now. That would look like this. current slot, next leader slot. So the current slot is, if we do it again, we get a different one. Current slot, we're in this one, and the next leader slot. Apparently there's still bigger gap, like quite a big gap in slots until the next leader is a Jito validator. So apparently there is quite, we have to wait quite a long time. What are those? Still 80 slots, which is still a slot, let's say it's half a second, so that's still 40 seconds. Now we're getting close. Now it's in 2 slots, and if now I request again, yeah, now the next leader, now this slot has passed, we're in this slot, and the next leader is in approximately 100 and something slots. So a minute to wait. And the next one is in 50 slots, which is like half a minute, not even. Okay, so my every 3 slot assumption apparently was incorrect. It looks like, from what I'm seeing here now, with the next leader identity, that it's always taking a bit less than a minute. And the next one, 3, oh, this one is quick. And the next one, yeah, this one again, about less than 50 slots, half a minute, not even. We're in the range of tens of seconds, usually under a minute, from what I can tell right now. But okay, that's the next leader. What else can we have a look at? Connected leaders. Those are quite a lot of leaders. It's listing the leaders with all of their slots where they produce blocks. I guess in the current epoch or the next. This and the next one probably. When the leader schedule is already valid. Let's send a 1 Lampert bundle. Whatever that means. Let's send a bundle. And there we need more things, which is gonna get a bit crowded, but whatever. So we need an RPC, and I guess even the public one should be fine. Let's try if this one works. Otherwise we find another one. The payer, and now we actually need some mainnet sol, but the payer is gonna be this key pair that I created earlier. Should have some sol now. Then message, we can add a message to our bundle. My first bundle. Number of transactions, I don't know, just 2. And Lamperts, this is how much I donate per transaction. So I'm gonna go with the minimum. Actually, I could be like even 500, but whatever. Tip account, there we gotta choose one of the ones that we had a look at, and we already chose this one. Let's go with this one. And that should be it. With that, we should be able to send a bundle. If we send that bundle, this is gonna get interesting now. Next Jito leader in 40 slots. So again, something around those lines, and it's counting down the slots until we can actually send our bundle. And bam, waiting 5 seconds for a result. And it's a bit hard to read, but the bundle got accepted in this slot by this validator, who is awesome, and the bundle landed successfully. Those are the 2 transactions. This was the first one, which is just gonna call the memo program and then send a tip to a validator. So all we will see here is we pay for the transaction fee and then we pay for the tip. So in total, 6,000 Lamperts. This guy, the donation address, gets a little bit, 1,000 Lamperts. And we send a memo, Jito bundle 0, my first bundle. Oh, that's where the message goes. I didn't see that. Ah, there's the message. Okay. Then the transfer for the donation. And that's literally it. That's all it does. And then the second transaction will look virtually the same, except that we have index 1 here. So that's the second transaction in the bundle, but it does the same thing. I again donate to the tip address and I've got this memo because that's what this CLI has as a default. It just builds memo instructions in a version transaction, and those are the transactions I send. So if I wanted to send some other transactions, I would need to change that code. So this is not particularly interesting yet, right? So we see 2 transactions, but that's not super fun. What is interesting though is that we managed to land them in the same slot. 222, 164, 440. Both of them are in that slot. And if we have a look at that slot, or the block actually to be more specific, because the validator managed to build a block, all except votes. That's interesting. Non-vote transactions were only 8. Only 8 non-vote transactions made it into this block. 2 of them are mine. Which ones? So we had 5EC and the one before was 453. 453 and 5EC. 453 and 5EC. They are exactly one tick ahead, so they are sequentially directly after each other. And both of them succeeded. Obvious. Well, so it's not so obvious, but yeah, that both of them succeeded. Both of them needed that much compute. It's interesting. It seems like the others were also the same transactions, except for this one. They also look like they were just a test for a bundle. So apparently the validator didn't build more than, it didn't include more transactions than this, than those 2 bundles. Because this also looks very much like a bundle. But this guy is a bit richer than me. Canary transaction 2. Whatever. So somebody else seems to be playing around with this as well. Anyway, point is, we have them in the same slot and directly after each other. Which again, for memo program transactions, doesn't help us much, right? There's no real reason why we would do that. It only becomes interesting when the transactions really depend on each other. Should we build something where that's relevant? We're in Rust here and we're not used to the Rust SDK. My brain is already at the capacity for normal operations, so we're gonna postpone doing that to some other time. Hello and welcome back. I want to add a few things. So here I am 2 days later doing the same thing. We know this command, it runs as a bundle and we have to wait 15 slots until our bundle gets submitted. Then bundle gets submitted and landed successfully. Great. So this is what we've already seen last time. Now I want to see what happens if a bundle fails. How can I make it fail real quick? I'm just gonna tip them 1 entire sol per transaction, which I don't have. This way I would now tip an entire sol, or 2 sol actually. And since I can't afford that, that bundle should not go through. But let's see. So I get, what? We have to wait 127 slots. Now that's unfortunate, because that's an entire minute. Okay, I guess we wait a minute. So yes, we can be unlucky that we have to wait quite a long time. And we're gonna have a look at that as well, why we have to wait so long, because I have another idea. Because my estimation of every 3 slots should be a Jito slot might still be true, just that here we're just looking at the ones who are connected to the block engine in Frankfurt. There we go. 10 more slots. And failed. Rejected, reason, some simulation failure. Transaction signature, runtime error while executing a bundle. A transaction in a bundle failed to execute. And then it doesn't submit the bundle, obviously. So none of that. We have a transaction signature here, right? Because we signed that transaction. But this transaction did not make it on the cluster. So here we don't find anything for that. It was not submitted, because bundles are only submitted if all of their transactions actually execute. So this is what you would see if it fails, right? A simulation failure. The block engine already rejects it. Now, let's have a look at those times again. The next scheduled leader. Let's just print that again. We have the next Jito leader in, oh, that's more, whoa, that's 100. That's a lot of slots. That's like in 300 slots. So yeah, we have to wait quite a long time. And I think that's because this block engine can only connect to validators that are connected to this block engine. So if we go with another one, not the one in Frankfurt, but for instance, the one in Amsterdam. Don't ask me why my mouse is looking so weird. I have no idea. Not even gonna question it. We go Amsterdam. Let's see that. of 5. So it's a different one than the one in Frankfurt, which have different target slots. So actually in Frankfurt, we need to wait longer than in Amsterdam. So the next available leader depends on which block engine we're connected to. Let's see, New York should potentially get all the US validators. So I would expect that there we're a bit quicker. So New York, we would now have to wait, yeah, just 3 slots. Now we'd have to wait still 50. That's still not too bad. And now another 30. So in New York, you get the next leader quicker. And let's be honest, if I just submit a bundle that is not really time critical because it's all my transactions, then it doesn't really matter if I send it all the way to New York or closer to Frankfurt. I can basically choose. It only really makes a difference if the round trip time to the block engine is relevant because I include other transactions that are already in the mempool. And it is of course super relevant for the validators because they need to be in close contact with the block engine. But for us as a searcher, or in this case just a bundle submitter, it doesn't really matter. So we can basically choose which block engine we take. Tokyo, such that we have them all. There we actually have to wait 100 slots. So Tokyo might also not be the quickest. Let's do all 4 of them after each other. Frankfurt, Amsterdam, New York, Tokyo. Tokyo takes long to respond for me. Yes, our slot moved a bit, but the next available slot, this is really not nicely formatted. But here we're 6-4, 6-5, 6-5, 6-5. So the quickest one this time I actually get in Frankfurt, but that's just luck. New York. New York takes longer to get it back, and Tokyo takes even longer to get a response. So there we already see if I connect to Tokyo, it takes way longer than if I connect to Frankfurt. So it does make a difference. But for our use case, it does not matter. But anyway, let's analyze this. So yes, it took a bit to get to the slots, but here we have 6-5, 6-8, 6-6, 8-0. So the next one would actually be in New York, and then Frankfurt, and then Amsterdam. So, but even if we take them all into consideration, we don't quite get to the next one is in 3 slots. Here we are at like 15. So yeah, that calculation somehow is not accurate. But anyway, 15 slots, still okay. Even waiting 100 slots or whatever. I mean, if that feedback should go to the user, then you need something like a spinner or something, because waiting that long, waiting for 100 slots, that's not nice responsive UI. You don't get all the speed that Solana has to offer because we need to go through the Jito leaders, but still acceptable speed. Still better than Ethereum. Yeah, anyway, so that's that. That's one of the reasons why we have to wait so long. Okay, one last thing that I want to do here, because for now, all we did when we submitted a bundle, our first bundle, 42 slots, I need to wait. If I would be like, oh, I don't want to wait that long, I'm not gonna go to freaking Frankfurt, I'm gonna go to New York. In New York, the connection is slower, but therefore I then get it within the next 4 slots. And my bundle also landed successfully. So I can send it on the other side of the world to the next leader. Yo, just real quick, stuff has changed. Jito changed the way how they treat their bundles that are submitted. They do now internally forward the bundles to other regions, such that bundle confirm time such as quicker. So let's have a look at that real quick. I'll just submit a bundle as we did before, 2 transactions, and I say hi, why not? And I submit that. And for Frankfurt, we only had to wait 6 slots, but at the end, we get the following message: this transaction has already been processed. Why? Well, most likely because in some other regions, there was a leader that was quicker than that. Quicker than just 6 slots. Let's try again. This time we have to wait 14 slots, so I'm fairly certain that we get the same thing, that actually this transaction has already been processed. So in case you're getting these errors now, that's just because the CLI doesn't really support that yet, that the backend just sends it to all of the regions. So the results now seem a bit weird, but the bundles did get accepted, and I'm gonna bundle explorer. I searched for that bundle a minute ago. It landed. I'm the signer. That was the validator identity. And those the included transactions. So my bundle did land, and my 2 transactions, my cross-region bundles, did hit the cluster. But yeah, here we get the transaction already processed. Just so you know that you're not weirded out by this message, it's just that a different region has submitted that. So really, we don't need to care about that much. We can just see our bundles are submitted faster because they're forwarded to many regions. They're now cross-region bundles per default, because Jito changed their backend. All right, back to the video. And once again, check this transaction where we just call the memo program and call a memo. And the more interesting thing though is in the slot or the block, this was the leader. So that's a Jito validator. In this one, there are 163 transactions, non-vote transactions, and mine filter by memo program. Then I see this one was mine, and this one, the 5VA, there 5VA, this one was also mine. So once again, within the next tick, sequentially, right after each other, in the same slot, came our 2 transactions because we put them in a bundle. But my point here is, it's just memo program transactions and they are independent of each other. So putting them in a bundle doesn't really make much sense. So I want to at least give you an idea how you can build a bundle where it does make sense and where you use your own transactions. So to make a nicer example, let's not do the memo thing, but let's do something where 2 transactions actually depend on each other. And because I'm too cheap to deploy my own program, I'm just gonna use a program that already exists, the token program. And we're just gonna do a token mint and then a create a token and then minting some. Does that add value that I show you this? I mean, I do want to show you how to add your own transactions into this bundle here. For now, we've just used what is there. So essentially, instead of this stuff, I'm gonna do get transactions of my bundle. That's what we'll do. And the function get transactions of my bundle, we're gonna return some version transactions. So let's start with transaction 1. So I copied the thing that we had earlier, and here we will remove the bundle instruction, the memo instruction, and keep this for later, the transfer instruction where we transfer to the tip account, but we only transfer it once. I want to do it properly. We only transfer in the second transaction, and in the first one we do not do any transfer. Forget that. So, but then we will need the pair, key pair, the block hash, counts, and Lampert. So I'll just put that in the function. So I just put in those things that I need into my function that gets me. So what do we now actually do? I don't know, something that makes sense. Here you can do whatever, right? And in a previous video, that's why I made it, we learned how we can use the Rust SDK, where we're going through the Rust SDK and build ourselves an instruction manually. If you want to call your program, that's how you do it. But I think I'm just gonna use some SPL stuff, some SPL token or whatever. I have the SPL memo. Do I want to add the SPL token library? I don't know what I want. It could do so many things. It doesn't really matter. Just do something. Let's play just with a system program because it really doesn't matter. So what we're gonna do is we're gonna create an account with a system program and pretend that this thing needs their own transaction, because let's pretend it was our program and it does so many things that all the compute is gone just for this instruction that creates an account. So we have a payer. Now this is gonna be a new key pair. New. Then Lamperts, I don't know, rent 2 bytes. They removed all the other output. It's just rent exempt minimum now. Base is 2 bytes and the owner is the system program. I keep it as the owner because I can. The quickest way to get the system program. Okay, so we create an account in one instruction, and then in the next instruction, we're gonna assign that account to some program. And I'm not sure if I can assign it if it already has a size. Might need to resize it as well. We'll see. System instruction. Let's see if I can assign. To a new owner, I'll assign it to Andy. Why not? So, and then in both cases, I think I need to sign with my account key pair. I'm not sure if that will work, and we will see. And here I just changed this line to get my transactions, and my transactions I put in here. Why is it like that? That should give me transactions. Yep, thank you, Rust Analyzer, for telling me that I didn't assign my transactions. So obviously here I'll just have my transaction 1 and my transaction 2, and that I then return. That's how you do it. Oh no, can't find crate, can't find crate. What the, what? Why can you not find the Solana SDK crate? Input output error. What is happening here? Don't forget to run this command is what I just learned. After whatever, freaking. Anyway, we'll get it to work, don't worry. God damn it, what? Could not compile crunchy due to previous error. IO error. Why do I keep getting IO errors? What? Mic check 1 2. Welcome back. Okay, so I had to completely restart my computer, and then I managed to get all the way to this. So those are 2 things I can fix. So if I do stuff like that, then it needs a lifetime. And here I forgot the pub key. Actually, I want to try without that. Please don't build everything again. Please don't build everything again. Just this one file. Everything again? No. 200 things again. Building, ding, ding, 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 we're fucking building, ding, ding, building, ding, 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 we're building, ding, ding, building, ding, 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 we're fucking building, ding, ding, building, ding, 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 we're fucking building, ding, ding, building, ding, ding, ding. We're thinking building, ding, ding, building, ding, ding, ding. We're freaking building, ding, ding, building, ding, this thing. We're freaking building, ding, ding, building, ding, ding, ding. We're freaking building, ding, ding, building, ding, this thing. We're freaking building, ding, ding, building, ding, ding, ding. We're freaking building, ding, ding, building, ding, this thing. That's what you do while you're waiting for it to goddamn compile. We're building, ding, ding, building, ding, ding, ding. We're freaking building, ding, ding, building, ding, this thing. We're building, ding, ding, building, ding, ding, ding. We're freaking building, ding, ding, building, ding, this thing. We're freaking building, ding, ding, building, ding, ding, ding. We're freaking building, ding, ding, with a warning and an error. Oh, that's not good. Building, ding, ding, building, ding, ding, ding. We're freaking building, ding, ding, building, ding, this. At one point, I'll get it. Building, ding, ding, ding. We're freaking building, ding, ding, building, ding, this. Great. Now I just need to actually build it, the binary, such that we can start it. It's totally building, ding, ding. Stop it. at some point, I have enough. But yeah, no more errors, so that compiles. Doesn't mean that it works, but at least it compiles. Bum 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 bum. Maybe another song. Don't you know, bundle it up. You got to bundle it up. You don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up. Okay, I need bass. Come on, give me bass on this thing. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up. You got to bundle it up, but don't you know, bundle it up, up. You got to bundle it up, don't you know, no, bundle it up. You got to bundle it up. Hey, it's done building, so let's bundle it up. Don't you know, bundle it up. Yeah, let's go. We have a built thing now that we can totally execute. I should loop more often, this is fun. There we have the CLI again. Let's see if it yeah, it starts. And we basically do the same thing as we did before. Literally the same. Let's go to Frankfurt though. With our key pair. Number of transactions is ignored now. Lamperts is still what we paid, but we only paid once. And that's the tip account. And let's see if we can submit our bundle with our own transactions. You got to bundle it up. And 10 slots to wait. And bundle sum accepted by this awesome validator again. And then landed successfully. Did you see? Oh, don't you know? You got to bundle it up, don't you know? Bundle it up. You got to bundle it up, don't you know? Bundle it up. Yeah, we got to bundle it up, just don't you know? We bundle it up. Yeah, we bundle it up. We bundle it up. I'm getting way too excited if I'm doing music. So let's check this. Can I has my browser, please? What do we see here? That's a transaction that landed with success. And essentially, it just created this account with those Lamperts and this account, which is a random account, which has 2 bytes and belongs to Andy now. Why does it belong to Andy? Well, here in this transaction, we just created that account. That's all this transaction did. But in the same slot, by this awesome validator, there are 105 non-vote transactions and mine. So how do I filter this now? Just load more and load more and load more. There. So this is the transaction, the first one. And the next one, the 65 NFF, is also mine. We can confirm that here. That's also mine. And what did that one do? That one took that account and assigned it to another program, to the end, which is not really a program. So what it did was stupid. But still, the point is, this thing depended on the previous transaction, right? They belong together. I couldn't do it the other way around. I can't first assign and then create account. This wouldn't work, right? So I had to do this second. That's the point. And they're using the same state. And then we also sent some tip to a tipping address. So just as a system program transfer to there, which is enough if we have one of them. In here, I don't send a tip. I don't need to send a tip in every transaction, just in one. And ideally, we do it in the last one. So me, the J1, I sent to the tipping address. And I worked with this account. So yeah, and that's Still a pretty, I would say, useless example, because of course you can do both of those instructions, this one and this one, in the same transaction. But let's pretend that those instructions were like bigger and for some reason they need their own transaction. They're just too big, working with too many PNFTs or whatever it is, too many accounts, referencing too many programs, whatever it is. And we still want to be atomic. Then we can bundle them up into one transaction and send them to the Jito block engine, which will submit it as a bundle. And then it's all or nothing. We had to bundle them up. Yes, that's how this works. You just gotta bundle them up. Don't you know? Bundle it up. You got to bundle it up. Don't you know? Bundle it up. Hey, you got to bundle it up. Don't you know? Bundle it up. You got to bundle it up. Don't you know? Bundle it up. You got to bundle it up. Yeah, and that's my Jito Bundles tutorial. Now, if I was not like super lazy, I could show you that it wouldn't work the other way around. If I had transaction 2 first and then transaction 1, then this wouldn't work. But for that, I would need to build this whole thing again, and that takes forever. One more time, we're building, ding, ding, building, ding, ding, ding. We're freaking building, ding, ding, building, ding, this thing. So with the swapped transactions, gonna do the same thing again. Boom. Oh man, we gotta wait 100 slots. You know what? No, we're not. We just send our bundle all the way to New York. Okay, still 20 slots, but whatever, faster still. And now, there we go. There we get a simulation failure for this transaction. Transaction bundle failed to execute. Panicked. Why? Well, because I'm trying to assign an account that doesn't even exist. There are no Lamperts on this account, and then I try to assign it to a program ID, so that obviously doesn't work. I would have to first create it. That's the advantage of bundles. If one transaction will fail, then none of them even get submitted. Which also means I don't even have to pay the validator. Like, he didn't take my tip. Would have failed anyway. So, yeah. Nice. All right, good enough. Let's finish this. Bring it home, Andy. Bring it home. So, thank you for watching this episode of Working with Jito Bundles. By now you should understand what Jito Bundles are and what they're used for, and I hope that this information is helpful for you, that you can build your own bundles. And then potentially even build bundles with other transactions that are not your own to do some arbitrage or liquidation. But that is a topic for another video, which might come sometime in the future. So make sure to subscribe, like this video, and watch some other videos. This is one where we talk about the Rust SDK that's useful for creating our own transactions with Rust, which we needed to do today. Let me know if there are any open questions. Join the Jito Discord. You can ask your Jito questions there. And yeah, I guess I'll see you in the next video. And don't forget to bundle it up. Cause don't you know, bundle it up. You got to bundle it up. Don't you know, bundle it up. You got to bundle it up. Don't you know, bundle it up. Gotta bundle it up. Don't you know, bundle it up. You gotta bundle it up. Don't you know, bundle it up. You gotta bundle it up. Don't you know, bundle it up. You gotta bundle it up.